The Ellinbank Smart Farm is a 230 hectare dairy farm, of which about 175 hectares is effective grazing area. So by that I mean by the time we take the buildings out, the laneways, the roads, the office building, there's about 175 hectares left for cows to actually graze in pasture. We do milk up to about 450 cows. This calving, which started Thursday the 1st of July, we're calving down about 430 animals. Pastures are predominantly perennial ryegrass across the farm, which the environment here, the temperature, the 1,000 mil rainfall makes it an ideal species for us to grow.
Hello, I'm Greg Morris and I work for the JPR Elevate Smart Farm. Just wanted to show you some of this new technology we have here at the Ellinbank Farm. And basically what this equipment does is monitors, or helps us monitor the live weight and condition of our animals. It's very important to monitor animal weights, and basically this technology here allows us to weigh the animals twice a day as they walk out of the dairy. So as the animal walks through and over this scale, it records her number using a ID reader, and from there sends her weight back to our database. With that, we can then monitor the changes in weight, which then can be adjusted nutritionally, one to get her to produce more milk, and on the other, help her maintain her health for a whole lactation. The second part of this system here, you could probably go and have a look if you want. Is this series of cameras through here. So as the animal walks through, there's a camera up here that's sending down basically a 3D image that then can measure how much fat, or take a measurement of the fat cover across her back. Now, monitoring body condition, or the body conditioning score, normally takes 2 or 3 of us, probably 3 or 4 hours if we were to try and body condition score 400 animals that we normally would do for research. But with this, again, morning and night, the animals can walk through, and again we can vary or monitor the variation in that condition, and again adjust the nutrition or our practices to better suit. The third function of this here also, as they work through, it actually uses some laser sensors that then allows us to draft the animals automatically if required to attend to. So this is probably one of my favourite parts of the new technologies we've put in at Ellinbank. It's called the Halo farm monitoring system. And basically what it is it's a real-time monitoring of any piece of equipment that we'd like to monitor in real time, and basically we've done that to select the most critical part. So for example here, this is monitoring the milking plant. So we've got to abide to guidelines and so forth to be able to supply milk to Bega, our milk supply factory. And basically this here is monitoring that for me. So for example, it's looking at, say, the temperature of the vat. So we can go into this unit here, we can go into vat 1, we can basically look through the history and create a chart on how and what the temperatures of milk have sat for the previous days. And it's logged this information for as long as we've had the system in. So as you can see here, basically every milking, every time the wash cycle has gone through, which is important for hygiene. It's monitoring levels, so definitely important for supply for the trucks and the factories. Some of the milk factories now are looking at installing this software or this information across their farms, basically to help with their transport and logistical pickups of milk, basically to save having to drive back and forth for small amounts of milk. If I go back here a bit, we can go into the other parts of the farm that we started to monitor. The silos, for example, we're monitoring these now. We can set up this system so a text or email will go direct to our feed company and let them know that we're out of grain. For example, here, so the truck should be on its way, based from on this system and what it's been doing, to refill this silo. And again, you can go through and set a series of graphs or alerts. It shows your consumption and also helps with monitoring errors or breakdowns. So if we were to go to here for a month, three months, basically it's showing all the times the cows are being fed and then when the trucks have arrived. So really good for keeping that history or information. So this is the Ellinbank dairy or dairy parlour. It's called a 25-a-side rapid exit. So either side of the dairy here we can milk 25 cows, and basically rapid exit being when the cows exit, this whole front of these feeding bays open and the cows all exit. So when the cow first walks into the dairy, she's got a transponder on her neck. Basically she'll walk through this reader and it'll assign her to the stall based on the position she's walked in the herd. As she walks in, the system then can allows us to give us any indication of health records or information required. You can put reminders into the system, and that just helps the workers with the jobs they need to do during the milking process. Once all the cows have gone in, a series of things happen. So the first thing that happens is it records what feed we've allocated. So this feed system here at Ellinbank has two different feeds, and we can individually or itemise how much feed each of that cow's getting, and that can vary from milking to milking. So once the cow comes in and she starts her feeding, we then get to the milking side. So these cups are then obviously put onto the cow, and this system will record a series of things. So milk yield, for example, it'll record milk conductivity, so looking at milk properties, milk qualities and so forth, and also health alerts like mastitis. The other things it records is anything to do with milking times, how she's progressing in that milking, but also cup removal. So as the milk flow starts to stop through this system, it'll automatically lift the cups off and prevents over milking, which is damaging to the udders and the teats. So I'm just going to show you the flow of the milk at the Ellinbank farm here. So basically, as the cups have gone on, the milk comes down through the cups and through the cup liners into the bowl. Basically, it was they'd be obviously sitting like this on the animal. As it comes through here, goes down through the first filter. This filter here we use for detecting mastitis or animal health problems in the milk. So basically, as it comes through here, if there's a problem, it will leave like little yogurty bits in there, and we can separate the animal. From there, it goes down in through this other little sensor, which does our conductivity, and then into the supply. From this, it travels along here, and into our receiving tank. From this receiving tank, it goes through a pump, and it's operated by a drive that basically, depending on how much milk's coming through, it'll be able to deliver the most efficient amount of milk for the next part, which is the cooling. From this pump, it heads up here, across the side, and back out and into this room. From there it heads along, down the wall here, across the side and in through the second lot of filters. So again, this filter system here, it's basically collecting dirt and mud and grass and bits and pieces that have come up on the cow's teeth, and it just does that preliminary filtration prior to the VAC. So once it's gone through here, it enters the chiller or the plate cooler. So basically it runs through a series of veins in here, and on the opposite side is a chiller or a glycol chiller, a bit like a refrigeration unit. And it has the ability to cool the milk from about 30, it usually gets here about 34 to 37 degrees. And as it flows through, out and into the vat, and it usually hits the vat at about 4 degrees. So we need to keep the milk sort of about that 4 degrees until the tanker turns up during the night and picks up the milk.
The Ellinbank Smart Farm has had an energy audit undertaken in the last 2 years, and the purpose of that audit was to tell us our current energy use and where we could make improvements to our current system. For us, that meant there were some clear opportunities around how we cool milk. So in the middle of summer previously, unfortunately our milk had been getting to the vats at way too high a temperature, which meant the vats had to work overtime to cool the milk down to that ideal 4 degrees before tanker pickup. Often our milk was getting to the vats nearer 20 degrees than 4. Part of that was the chiller system we had wasn't as efficient as it could be, and again, historically, it was put in place when the herd was smaller, there was less volume of milk per animal. So as we increased animal numbers, as production per animal improved, we ended up with milk going through there and not cooling adequately. Over the past 18 months, we've had a new chiller system put in. That is now coupled with or will be with a CO2 heat pump, so we can actually collect the heat from the glycol more efficiently and heat our water 4 times more efficiently than we have been. Our milk is now hitting the vat pretty much on target temperature, saving us a lot of energy and overall improving our system in the dairy. One of our aims here at the Ellinbank Smart Farm is to try and reduce our reliance on grid energy. So the energy we get from the power stations down the road. And part of that, as you can see behind me here, is putting just under 100 kilowatts of solar onto the roof of one of our buildings, and inside that building is also a 100 kilowatt hour battery. So we can fill the battery every day and we can use the energy when we need to offset energy we draw from the grid. And in the middle of February this year, as an example, that 100 kilowatts of solar was supplying about 43% of our energy needs on those days, which on a lovely sunny day is fantastic. Obviously today, we're not quite there, but it's still supplying some energy. Our aim is to increase that 100 kilowatts, probably up to 200, 300, 400 kilowatts progressively. So we're in effect completely independent from the grid. We will do that with some additional battery storage, because you can imagine a dairy, milks in the morning, sun's not shining. Milks in the late afternoon, sun's not shining. And we produce all the energy in the middle. So by the batteries, we can store that and then use it when we need to. The other thing we will be doing here is putting in some wind turbines. So small wind turbines to demonstrate the technology, but they will also supply energy when we need it. The other feature here, and you can see that we've got some beautiful slopes, is we'll actually be putting in a small water turbine. So we'll gravity drop water down the hill in a pipe, have a turbine inside the pipe, that will generate additional energy, and then a small solar system that'll pump the energy back up the hill free of charge. So it's almost like a closed loop. And again, demonstrate an alternate energy option for us. The other part of the system is farm vehicles. On this farm we have a small fleet of ATVs, side-by-side vehicles. We're progressively converting those to electric. The aim will be, again, and in my mind I think of a school bike shed. They all come in at night and you plug them in and they're all charged, ready to go the next day, all off our own energy.